Hello everyone, welcome to this lesson. So in this video, you're going to look at how the power rule and the chain rule work together when differentiating certain functions. Sometimes when we are asked to differentiate a function, we cannot just pick one rule and finish. So there are times you have to use multiple rules, either 2 or 3 rules in order to get the derivative. Okay. So we focus on the problems where the power rule and the chain rule combine. We learned from our previous lesson that for power rule, when you're given a function c f of x, which is equal to x exponent n, to differentiate, then your f prime of x is going to be n x exponent n minus 1. Okay. But the question is, what if the power is applied to a whole function, not just x? Like maybe giving f of x to be 2x squared plus 4x plus 7, or exponent will be power n. How are you going to differentiate this function? You see, that's when we combine the power rule with chain rule. Okay, so let's dive into the lesson. If n is any real number, the derivative of g of x exponent n is equal to, and multiplying g prime of x multiplying g of x exponent n minus 1. What this is saying is that when you're given a function, say g of x exponent n, when you're asked to differentiate this function, first of all, you bring the power n here in front, then you differentiate the inner function, which is g prime of what? X. Then we maintain the function, then we subtract 1 from the exponent. Okay, so here you can see that you have a power rule here, which is n multiplying g of x exponent n minus 1. Okay, then when you multiply this by g prime of x, we are going to get a chain rule. Let's prove it and see. So let f of x be equal to g of x exponent n. Okay. Now we can say this is a composite function. So let u be equal to g of x. Okay. Which implies that you have f of u to be equal to u exponent n. Okay. Now from the chain rule, the f dx equal to the f du multiplying du dx. Let's find the f du. So we have the f du to be, so here you're having u exponent n. So you have to apply the power rule. Okay. So n come in front here. They write u, they subtract 1 from the exponent. Okay. So this is the power rule. Okay. Now you have to find du dx. So from u is equal to g of x. U is a function of x. So we're going to get du dx to be equal to dg dx. Okay. Which implies that our du dx is equal to g prime of x. Okay. You're going to have our df dx to be, we had the df du to be nu exponent n minus 1, which is the power rule. Then when you multiply it by du dx, which is g prime of x. So you can see that when you multiply the two together, which is giving us the chain rule, okay, which is n u exponent n minus 1 multiplying g prime of x. But don't forget that we said that our u is what? G of x. So you're going to get n multiplying g of x exponent n minus 1 multiplying g prime of x. And we can see that this is what we had here. You can see that when you apply the power rule and you multiply the g prime of x to it, we get a chain rule. Okay. Okay, so let's have some examples. Now, we are to find the derivative of y is equal to root of 1 plus x squared. Okay, so let's solve it. Now we can write root of 1 plus x squared as 1 plus x squared or exponent half. Okay. Now, according to our rule, what you're going to do is you're going to bring this half in front here. Then we differentiate what is inside the bracket. Okay. So when you differentiate 1, you get 0. When you differentiate x squared, you get 2x. Okay. Then we maintain our function that was given to us. Then we subtract 1 from the exponent. These two will cancel these two. So you're going to get x multiplying 1 plus x squared exponent negative 1 over 2, which is the same as x exponent root of 1 plus what? X squared. Do you get it? Our second example is to find the derivative of y is equal to sine x exponent 4. Okay. Now, applying the same principle here, we'll bring the 4 in front here. Okay. We'll differentiate what is in the bracket. When you differentiate sine x, you're going to get cos x. So you're going to get cos x. Then we write our function given to us. They subtract 1 from the exponent. Okay. So this is going to give us 4 cos x sine x to the power 3. Okay. So let's solve another example. We have to find the derivative of y equal to x cubed minus 1 or exponent 100. Okay. So we are going to get our y prime of x to be, we'll bring the 100 in front here. We differentiate what is in the bracket, which is x cubed minus 1. When you differentiate x cubed, you're going to get 3x squared. Okay. When you differentiate 1 is a constant, so you're going to get 0. Then we'll maintain our function given to us. Then you subtract 1 from the exponent. Okay. So you're going to get 300x squared multiplying x cubed minus 1 or exponent. Okay. Okay, so try this question and let me know your answer in the comment section. So find the derivative of y is equal to e exponent x plus 1 to the power 2. Okay. Thank you very much.